All right. Hey everyone, welcome to another deep dive. Today I have with me Lucian from RISC Zero. Welcome, Lucian.
Hey Nick, nice talking with you.
Yeah, so I think the only way to actually intro you is to say some crypto lore about you. So Lucian was actually on I met him at a hackathon and this was back, I think the first hackathon we did together was, what was it, like 2017 or something? And
Yeah,
then we did another one in 2018. And that was whenever we came up with the idea for a proof of work oracle, which later developed into Teller. Um,
yeah. So I helped you build like the first client effectively, the actual proof of work logic.
yeah, it was like a little Python client. It was
Yeah,
it
just like hashing
was
and
a fun
verifying the
time.
chain and making
Um,
sure that the difficulty was sufficient. That was I can't believe you launched an entire business out of that. That's absolutely wild.
yeah, no, I mean it's crazy to see how far the space has come since then.
Yeah.
And Lucian and I've kept up. But I'll let quick intro since you were doing hackathons back in 2018. What have you been up to and how did you end up kind of here at Risk Zero?
Yeah, making me go way back. I started as a software engineer in blockchain, worked at a few management consulting projects, led a product development team at Deloitte for a number of years, and launched a few products there. One of which happened to be the first Avalanche subnet, um, and it was a FEMA disaster recovery and reimbursement platform. And yeah, then I went and I worked at Ava Labs. I became the PM leading subnets for a while there, and I led solutions engineering. And I now lead solutions engineering at RISC Zero and soon to be Boundless. Boundless is a ZK universal application. It's a on-chain marketplace for requesting and filling zero knowledge proofs. Um, so this is like we're in the process of launching this new boundless network with a token that's coming out soon as well, and live mainnet beta where both ZK provers are earning ETH and like right now on base mainnet, and where like we have protocols where we're essentially running um, zero knowledge proofs for things like Ethereum full consensus. We were the first people to prove Ethereum consensus. And yeah, we'll use the call to kind of go more into that. But that's kind of like a high level. I help projects get to production with this technology. So I've helped both provers spin up like massive data center scale clusters, and I've helped like major blockchains like the Ethereum Foundation, Solana Foundation are both users of RISC Zero, as well as like all of the dApps and other L2s that use our protocol as well.
All right. Well, I guess first the thing I didn't really know is Risk Zero the company turning into Boundless, or what's the split here?
Yeah, RISC Zero, you could think of them as like the open source cryptography company that
Okay.
built the first RISC-V ZKVM, and they have the RISC Zero ZKVM implementation.
Yep.
Um, and yeah, that's fully open source. We've built a full technology stack, and we've effectively spun up an entire industry in RISC-V ZKVMs. So I think it's important to drill in like what is a ZKVM? Like we've been hearing about ZK like almost our entire Ethereum careers. Like why is it happening now? Um,
Sure.
but yeah, so Jeremy and Frank, the technical founders of RISC Zero, like they came up with this amazing invention where rather than actually building application specific zero ZK circuits, what if you basically write you take the RISC-V instruction set and you write a ZK circuit that takes the assembly code and transforms anything that can compile to RISC-V into zero knowledge compute.
So it's like a general purpose one.
Yeah.
Um,
Yep.
yeah. So I mean, the way I sorry, the way I usually understand it, like in the past, like we would write, like the application specific ones would be there was this language, what like Circom files
Yeah.
back in the day. So like tornado cache, you would say like, okay, here's a Merkle tree. And here's, and you would have to use this very specific language to have, proof that something is within this Merkle tree. And so you would have to write out all of that logic in this CIRCOM language, and then compile it into a zero knowledge proof, and it would come out with a prover program. And then you would also have this solidity file with all of these number variables that would be the proof. But what you guys did is say, listen, like you actually don't need to write the specific logic in Circom code anymore. We can just verify that you can use our program to verify you enter what the program is, and then we can verify that it ran correctly,
Yeah, we
essentially.
could run arbitrary Rust code, and anything that we can compile into RISC-V, we can turn into a
Anything
program.
besides Rust?
Yeah, you can, but there's overhead.
Sure.
So, like, it's the computational overhead associated with things. Rust is very efficient, it's memory safe. So, the performance characteristics of Rust currently just make it kind of perfect. Um, but we have demos where we can take WASM code. We have demos like it is possible to compile other high level languages, but you have to target a very specific CPU architecture instruction set. And most high level languages have moved on to like 64-bit, or
Sure.
they have like slight variations with more instruction sets, things that we intentionally didn't include in our program because the performance versus like benefit trade off, it would just add too much overhead to keep expanding the instruction set.
Yeah, I mean, I always just laugh. It's like such a crypto thing where they're like, you can write it in any programming language that's useful for devs, like Rust. And I'm like, really? Like, this isn't really my first choice of accessible programming languages. Um,
I think Rust has a bad rep, but I also think it's also perfect for crypto in the sense that like we are operating in a resource scarce environment to begin with, right? And the reason that we were resource scarce actually is changing because of zkVMs. But this ability to basically like use as little memory as possible and while running a program um, is basically only possible with a handful of languages, and Rust happens to be one of them. Um, I would say just give it a try. It's actually much simpler. Oh,
I
and there's
have
one
written
more.
some Rust. But I've written like about as much Rust as I've written like Circom and other ones. So it's
So
not,
like
yes.
RISC Zero is absolutely cracked. Like we have such good engineers here. And just to like we've heard that feedback before. So what we did is we took the Foundry toolchain for Solidity codes, and you could use Foundry inside the ZKVM and compile your Solidity code into a functioning ZK program.
All right. All right. We'll give it some tries.
Yeah.
Um, Anyway, so back to kind of what Boundless is and what ZKVMs are. So there's this idea like, okay, so we want to be able to prove things because this is always the problem with like zero knowledge proofs, right? Like you're always just like you can prove things without revealing any information, and then the people go, okay, so what am I proving? Like
Yeah.
what I actually like? Can you give me a concrete use case or something like this? And
Yeah, so zero knowledge has a few security properties, and like obviously the ability to build privacy enabling applications is like the most obvious one. But there's a second order consequence, and this property is also part of the cryptography. But because I don't have to share information to prove that execution was done correctly, I can basically update the block hash without sending the inputs and the content. I can literally just prove it to you cryptographically that the block hash has been updated correctly. Then, just for your transactions, give you the minimal amount of information to like show that your transaction is included, right? So what the current network architecture for Boundless is focused on is actually the compression of zero knowledge proofs. And this basically allows us to compress the entire consensus of Ethereum, like all the nodes and all the BLS signatures. We run that in the ZKVM, and then we have this valid update to consensus that we are going to start running in parallel to current Ethereum consensus. But with the Beam chain and future updates, it's actually going to reduce the hardware requirements for validators and potentially remove the need for validators at all, because you don't need multiple nodes independently re-executing and verifying every state transition when you have a compressed ZK proof that it happened. Um,
Yeah, so
so
if I can like maybe simplify it, you can correct me if I'm wrong. Like the old way that blockchains work is everybody sends their transactions to a mempool. We round robin pick one of the validators. It's your turn to pick. He and every other validator runs the compute on it, on that list of transactions based on the state, and we update the block hash. And since everybody ran it, we can all agree that it was executed correctly. What
yeah,
ZK allows you to do is just one guy runs it, and then he proves to everybody else that he ran it correctly. So there's no need to do the duplicate or have thousands of validators or anything.
or wait until you have a super majority of like
Yep.
the tens of thousands of disparate nodes all over the world, like reattesting to the exact same data and computation. Yeah.
Okay.
So I think the killer app is like when you look at the infrastructure and where the costs lie within modern blockchain systems. Um, the data replication aspect of blockchains for mature and highly used blockchains, right? The data aspect of it is one of the most expensive, and it's like the long tail, right? You pay gas once, but then your transaction gets stored on Ethereum forever, and every node has to replicate that transaction and store it forever. Um, so like the state bloat issue that was at the very origin of like the debate between account based and UTXO based, like the Ethereum versus Bitcoin scaling discussions, like we literally have a solution now that doesn't have that problem anymore. Like we can keep growing state, but we don't have that long tail cost of data replication and maintenance like we do for every single node. You still have to run archive nodes, like you still have to replay the entire blockchain, but validators don't, RPC nodes don't, and like most actors and most players within the ecosystem are basically keeping redundant copies of the entire chain, despite the fact that they only care about like a tiny sliver of it. So those economics are going to get completely torn up.
Well, you could say also though, because this is the one piece that probably boundless that we can get into with boundless. Like you run into the obvious problem. Okay, like you can view that the state is updating, but then you have two issues, right? You have the data availability problem. Somebody needs to show it so that way, like because there's a problem is let's say the person that you assign to be able to run this doesn't do it and they just shut off, right? Now you have this liveness issue. So how do we solve this liveness issue and this it's kind of concurrent to this data availability issue to make sure that they're not lying?
You basically just introduce Boundless.
Exactly. Okay, that's what I'm saying.
Yeah.
How does it solve this?
So Boundless is a two-sided marketplace. It's built into smart contracts, and it can be redeployed on any number of blockchains. We're starting on base mainnet today, but we're going to deploy on Ethereum mainnet. We're going to build a Solana version. The idea is basically it's the blockchain native way to request and fill zero knowledge proofs. So with Ethereum mainnet, what we're doing is essentially like we have timelines, And the timelines are actually like really easy to see in a visual format. I will just open a recent order and just kind of show you. Let me make sure that it's cool. So this is just a single order, but the chart speaks volumes. Essentially, what you do is you have a ramp up period where someone requests a proof, and in this case, it's us making a request. We don't know who the prover is who filled this, but essentially, what we do is we upload the inputs required to make a valid state transition in a zero knowledge proof. And we let people execute it on their own machine before they start proving. Then we start an auction for proving, a reverse Dutch auction where the price ramps up over time. And there's so much proving capacity added to our network that everyone is currently locking orders in effectively at zero. Um, I'll get into why that's the case in a bit as well. So you basically like commit to filling this order at a certain price point that pays you ETH, and then you have to submit the proof, and it's verified on chain, and the transaction is complete. The prover gets paid after submitting a valid proof, given the inputs to this. We also have this functionality where you could have a callback where the person who submits the proof then triggers a side effect after verifying the proof on chain. For example, like submit my proof and then update the latest block hash on my L2. Right. So you basically, we use slashing specifically. So the person who locks in this proof has deposited, and if we go into more details, we can see the lock stake is $3.50 in USDC. This is actually where the Boundless token comes in. ZKC is going to be used for staking, and that's the utility of our token. And essentially, like if they misbehave or if they don't fill the proof in on time, right, which is this timeout, their stake becomes a bounty, and anyone can fill this and claim their stake. So there becomes this open race to fill this proof. And the idea is basically like we're trying to guarantee that you will get a fulfilled response before the expiry period. And we're using token economic incentives to create the liveness guarantees that honestly like have never existed in ZK to date, because every other proving infrastructure is centralized, run by the team, closed source, right? And this is kind of the first of its kind.
So let's say like I think a good example would be like on base, you want to prove that a deposit happened on Ethereum. Okay. So
Mm-hmm.
what would the inputs look like for this?
On base, you want to prove that a deposit happened on Ethereum.
Let's say you were building a basic token bridge, right? So
Yeah.
I deposit obviously some TRB in my bridge contract on
Yeah.
Ethereum, and now I want to prove that it's deposited, so then I can mint you a base TRB, right?
Mhm.
So
Okay.
what would my inputs be?
So you can leverage this proof that we are creating about Ethereum consensus. First, you have to have a valid block hash that says the Ethereum network has agreed that this is the latest block hash, right? We are generating that currently. We're calling it the signal Ethereum, but the consequence is that you have a portable proof that proves the latest block hash of Ethereum on any other chain. You could do this on Solana too today. And then what you would do is you would have a Merkle inclusion proof of your deposit into that deposit contract that ties back to the latest block hash.
Okay.
Yep. And this sounds complicated, but I remember how I told you that we
So this
built
would
this.
be like in Rust, I would write.
Well, we did that for
Or okay.
so you would use the tool that I mentioned earlier in our call. It's called Steel, and you would just run Foundry, and you would just read a deposit in Foundry at a specific address, and we automatically handle all of like the Merkle inclusion proof behind the scenes. So leading industry tool chain, we literally just run it in our ZK VM, and you basically have this very easy workflow where you can prove that deposit happened.
There you go. Um, all right. I'm guessing, and then would so I would make that request on base,
Mm-hmm.
and then you guys would do a callback with the proof that I could say do a callback to the mint function with the proof that then mints the bridged token, right?
The way that you would do it is you would write a program that says, if I have a valid deposit with amount and contract address as inputs that you independently verify, right? Then mint amount and like address as output. So with the ZKVM, you have the ability to write to a journal, and within the proof, you have the ability, like within the Ethereum runtime, you have the ability to check whether like certain inputs were written to the journal and are valid. So you would basically use the ZKP for the authentication, and you could authenticate validity of the transaction, right? And you can validate also the amount and the addresses being used in the withdrawal.
All right. If
Yeah.
I'm, oh, this looks shockingly like early oracles. Um, if I'm gonna make a prediction on, I'm guessing you guys will end the callbacks and even the requests on chain, because that's what oracles used to do. You remember what was it, Oracleize, right? You would make the call on chain to go fetch the data, and then they would go and post the data back on chain, and then you could run an optional callback. But then like as soon as gas spiked up, everybody was like, F making, 4 calls on chain. It's like this is not
Yeah.
happening. So,
Well, I mean, that's the beauty of our architecture. So we're
so
multi-chain native, and really your request is where you need finality. So if you need the proof on base, you could make the request on base.
do you even have to make the request on chain? Could you just,
We already have
yeah,
off-chain order flow built in.
yeah, that's
So
what I'm guessing everybody will just do. Like,
yeah,
why would you pay gas to post it on chain?
yeah, exactly. You wouldn't necessarily need it. The one kind of caveat is like why is because of independent auditability,
Yep.
and there are certain applications that are securing such high value that you literally want the ability to make it unstoppable. So we have this other feature where it's called the smart contract requester, and you can just send money to it, and it automatically submits the request for the update and pays into the contract. And then you just make it permissionless, and you can't stop the L2 anymore.
Sure. But I mean, like in our case, like in our example for the token bridge, right?
Yeah,
Like I'm guessing anybody can generate this proof. Right?
anyone can just.
Like I know like there's the network and it probably does it really, really fast. But like I could probably do it on my Mac, right?
You can. Yeah,
Yeah.
yeah, yeah.
So
We
like
actually.
if it was my bridge, I could just download the code, run, make the zero knowledge proof and punch it in myself, and I don't even need to use the network at all, right?
Yeah,
That
that's the beauty of our stack,
that's
right?
like the to me that's like the censorship resistant guarantee at the end of the day. It's like
Yeah,
you actually don't even need the network to use the thing. Um,
you actually can have your own users generate your own valid proofs,
yep,
and like now you have a permissionless bridge.
there you go.
So you can make this in such a way that you can step away from a ZK application basically for the first time. Um, there's always a catch, right? Like there's always a caveat. The caveats are like there's computational overhead with generating ZK. And while you can generate small proofs, and I would say like the Oracle example that you have is actually a small proof.
Sure.
I would back of the napkin estimate it at around like 5 million cycles. RISC-V cycles probably doesn't mean a lot to you, but like
Okay.
on a Mac, that would take like, I don't know, probably like between 20 minutes and 20 seconds and a minute without the final step, the Groth 16 wrapper, which is required to actually submit it on chain. That's currently something we're still GPU accelerating. But yeah, so like the idea is that you have the ability to run much, much, much larger programs. And at that point, you have this issue where like you can't reasonably expect end users to generate these proofs. Um, but I find that this is actually just like an engineering problem. Long term, we will have client side proving. Every time you hear that a device is like AI ready, right? They are doing the hardware acceleration that we leverage. You just need more RAM and you need more compute cores for like small field cryptography. And like it right now, it just happens to be that NVIDIA GPUs are the most cost effective in terms of electricity costs to do this. But if your proofs are small enough, you'll be able to do it on a mobile phone. And at that point, like we can start talking about the privacy preserving aspects of ZK again, um, because yeah, that's what you need. You need basically to stop sharing the inputs, do it local, and then you can't actually re-extract the inputs. You just know that the program ran valid computation and you don't have access to the data and you're not publishing the data on chain anymore.
I mean, this is like the dream, right? This was always
Yeah.
like the crypto dream is we all run our own nodes and we store our own data and then we publish, a zero knowledge proof that proves I have this data. And then, even I think it's like the Anoma guys, they talk like pretty soon we're not even gonna have global consensus. Like, well, why do we need you only need global consensus for certain things. You only should like prove up to the level of consensus that you need. Like, so me and you, if we're trading, only you and I need to know. Nobody else really even
Yeah.
needs to know.
So Anoma uses RISC Zero.
Yep.
However, they have a multi-proof system set up because they want privacy. So they do the least amount of work possible client side. And then the actual operation of the network that can be aggregated and bundled, they offload to us.
Yeah, but like what's do you actually see it like now we'll get into the philosophical questions. Do you
Yeah.
do you actually see it playing out this way? Because like the other architecture would be like the company, the company whose app is running stores your data. They provide the proofs and you just sort of interact with them, and that's a very different experience than you owning your data, right?
Yeah. Yeah. I think that we're in a technological progression. And I think that ZK VMs have accelerated ZK development massively, right? Dan Bonet was basically saying that previously, like end of year, like you do his master's program in cryptography, and his assignment was like build an application in ZK. Now it's too easy, right? Because you just use a ZKVM and it's like a 2 week project for like a grad student. So I
It's a
think that we
weekend
are,
hackathon. This is
yeah, yeah, yeah. It's gotten a lot easier, and the thing that we've unlocked is developer velocity. Once you have developer velocity, then you build infrastructure in order to allow it to scale. And Boundless specifically takes the cost of proving by making it like a completely free and open market for anyone to participate as a prover. We have demonstrated that we can push the price of actual ZK compute to zero, right? Um, the, there's a bit
well,
of term,
have you? I
yeah.
mean, yeah, discuss a little bit.
Yeah. So why are people accepting proofs at zero? Right? Like that's
Right.
illogical. Like they're wasting electricity and
Well, I mean, I
opportunity.
would say airdrop, right? But is that not valid?
Well, here's the deal. So we
Okay.
invented something else. There's a trend here.
Okay.
We invented this thing called proof of verifiable work, which is a change to the circuit so that we can keep track of every single like CPU cycle of RISC-V that resulted in a proof. So we can basically say this prover did 25 billion cycles. They could take that, like, they could take the aggregate and submit it on chain and withdraw a reward that is proportionate to their contribution to the network. So we have this way to permissionlessly incentivize provers with tokens directly proportional to the amount that they have contributed in compute to the network.
All right. So I guess that sort of makes sense to me. I think the bigger thing that I have with a lot of these, so you could say it looks more like a proof of work network than a proof of
Okay.
stake network, right?
Yeah. Yep.
Yeah.
We're making Ethereum proof of work again.
Okay. Um, there's some,
And
pr
every other chain eventually once we finish the guest program.
I mean, you probably are aware there's some problems with proof of work. Um,
Mostly it's wasteful.
it's wasteful, but we also it's kind of centralizing, right? Like
Yeah.
it's like it's sort of turned into this hardware race where like
Right.
now it's not even like either it's about like coming up with ASICs first or it's like a geopolitical energy contest, which is like ugly in and of its own way.
Yeah.
Um,
Yeah.
so like
So
yeah,
let's actually like take a step back and what's the difference between proof of verifiable work versus proof of work? Proof of work, as like we both know because this is actually the POC, you're actually just grinding random hashes by changing the nonce until you get something. Every result that is not exactly what you wanted, right? Like the difficulty is too low, not enough leading zeros, you throw it all away. We don't do that with ZK. Every proof is useful, right? We are literally running a compression function for blockchains. You don't have to do it again, right?
sure.
So we eliminate the waste in proof of work through this mechanism. And then the second part was ASICs. Eventually, I think ZK will have ASICs. However, where we are currently within the ZK industry is like last calendar year, we had a 320 times improvement in efficiency with just tweaking the algorithms and the cryptography being used. So if you don't have a stable algorithm, you don't have a stable target for ASICs, right? The end result will be an ASICs that accelerates zero knowledge proof eventually. But you actually have to have this massive convergence of like algorithmic stability. And I feel like we are quite away from there. Since last April, I think there's something like 19 ZKVMs and a lot of them like including some projects that got like over 50 million in funding to just build their own version of the zkvm. They were just like, let's take plonky 3 Polygon's proof system and just like slap it on this other kind of design, right? And that was it. That was like their innovation. So it set off a bit of a gold rush, and VCs just started pouring money. And we at RISC Zero, we realized this. We're like, someone is going to make an algorithmic breakthrough. There is way too much money to assume that, like, because our founders invented the technology, they'll be able to keep up. So we built Boundless to be proof system agnostic. So we don't care who wins really, as long as they do it within Boundless. And since we're the only permissionless like uh, ZK proof marketplace, then it's likely that we're essentially going to be able to scale up and then we'll just consume other proof systems. And some people like tried following this part of our roadmap as well, and they built their own prover marketplace. It's okay. I wish them luck. But in reality, I'm just going to
We
take their
won't say
proof
any
system that
names.
is open source and I'll just like crush them as well. So there's other teams, right? Like ZK Sync, they're building Airbender. It's a ZK VM, and they don't want to build their own ZK proof marketplace, right? Like they are an L2. It's not their market. Like they'll choose to use our technology because it's the most permissionless and has the best security guarantees for them. And yeah, now we can support Airbender.
Well, I mean, I see it moving like there's two kind of directions for the prover market. Kind of like the proof of work market, right? You either it is a generalizable GPU technology. So like just listen, GPUs will be rented to whoever's paying them the most, and it will go whether you're being used for AI or for gaming or for anything, like you're part of that marketplace, or you move into the your specialized hardware marketplace, and then it's whoever can create slash accumulate it the fastest. And then on
Yeah.
top of that is the energy question, um, which
Yeah. I mean,
if you hit a big enough scale, that becomes an issue. Um,
realistically, like I don't think that we have an answer. Long-term ASICs will become inevitable if the stability of the algorithms appears and the profitability to do so exists. Um, it's just like history. It's going to repeat
well, I
itself.
mean, this is like with AI too, right? You're gonna have
Yeah.
AI ASICs as well, and it'll be
Yeah, good point. You bring up AI. There's actually this like really funny coincidence with regards to what infrastructure and what technology works incredibly well for our proof system as it is today. Because we did target consumer grade GPUs. Currently, we only support NVIDIA GPUs. In our previous version, we did have Apple Metal acceleration as well, and we'll add that back in shortly. So you can participate with like your laptop or like a Mac Studio. AI infrastructure is very, very similar to what we actually need for high performance ZK proving. You need lots of VRAM and you need a really high compute core count. We are different though. Like we are fundamentally different. So renting like the top of the line, like H200s in the data center, unfortunately, it's just not cost effective. And like the best type of graphics cards from a price performance ratio currently is 5090s because they have a very high compute core count. They have very high VRAM. And when you cluster them together, you get really good performance. So like we don't have to compete with like industrial scale machine learning clusters. But when they become obsolete in 2 to 3 years because they're not energy efficient compared to the latest, they're perfect for us.
sure. Yeah, I mean, I think the other question would be on just, you're losing me with data specs on
Really? Yeah.
machine
So
specs. I don't do the GPUs, but I think
have you
um
played video games or built a like gaming
yeah,
computer
yeah, yeah. No,
recently? Yeah.
you were high level enough, I get it. But I think,
Yeah.
moving back, just the one of the big benefits of Ethereum, kind of like we were talking about, was that it's validate, you know, you want home validators, right? So you
Mhm.
want everyone to be able to prove this whole thing. Is this still allow for that? And like what's the bottleneck here?
So if we target consumer grade graphics cards, then like the people who have like a rack with eight 5090s are going to do extremely well. There is like at the end of the day, if you build something in a data center, there are certain economies of scale when it comes to cooling performance, like the relative efficiencies associated with like having a lot of infrastructure around you still very much helps. But like we are seeing in our mainnet beta, there is a high school student who's at one point got top three in our leaderboard with rented GPUs, right? And like we're very, very early. Like we're
Sure.
very early because he just tuned, overclocked, and like rented relatively cheap. And the end result was that he was actually able to be extremely competitive. We also have publicly traded companies submitting proofs,
All right.
right? Like there are a lot of ZK miners. I mean, there's a lot of like Bitcoin miners. There were a lot of Ethereum miners. The overlap in hardware with like the Ethereum mining setups that people have, they're very close. It's not exact. Like you have to structure the system a little bit differently. It's a different algorithm that you're mining at the end of the day. Um, but more GPUs is more better. And yeah.
Yeah. I guess kind of pivoting on this a little bit, we can talk what are the implications kind of ZK for this space. Like one of the big things I think about, and probably the last couple people I've had on the talk, we've talked the social layer, right? Like the importance of a social layer.
Mhm.
Um, in my example with, like the token bridge done completely by ZK, however, there is no social layer. If you have interop completely with ZK finality, you almost lose the sovereignty of each blockchain in some ways. Um, yeah,
That's a funny way to put the fact that you have a higher security threshold for bridging.
it's
But I see your point. Like,
yeah.
it's hard to fork a ZK application unless you build safeguards into the program in advance. Um,
Well,
yeah,
you're very, very, exactly what the security is, right? Like,
yeah,
like that's the pro. Like with a proof of stake network, listen, if I break it, I steal everything. Whereas like now, like if you have a proof of stake network with, even a couple $1 million, then you maintain your ability to do a social fork. Nobody's hacking you, right? Like you can just revert back. Like it's not really there is no economic security that actually matters. Um,
yeah.
whereas like now we're moving into a world of like hyper economic security, it seems.
Yeah, I mean, it's a philosophical question. And to be honest, like with the implementations that I work with now, I think we have a lot of catching up to do with regards to the maturity of existing infrastructure. Um, the way I see it happening is we're going to see entirely new blockchains designed from the ground up to take advantage of ZK VMs. Um, we already have. Like one example that I like giving is Highly. Highly is a protocol that it's not exactly an L1 because it doesn't have shared state between its chains. It's a chain of chains, and then you use proof aggregation, and then you submit a root on the main network. It's basically like uh, probably underselling it by calling it a launchpad for other ZK applications to take advantage of the benefits of aggregation while sharing like a connection to Ethereum mainnet in aggregate. So yeah, I think there's going to be like a new class of applications being designed. But as I mentioned before with proving Ethereum, we're also just integrating with existing technology stacks and just running it in ZK. It's going to run in parallel with Ethereum for a long time. The Beam Chain roadmap was supposed to be 5 years, but we just demonstrated that we could do it now. They weren't aware that it was possible to be done. In fact, before the Pectra upgrade, it wasn't feasible actually to be done. It can certainly use optimizations, but the optimizations are effectively a reduction in price and a reduction in latency. That doesn't mean that like the social consensus layer of Ethereum goes away just because we're proving it in ZK. Quite the opposite, actually. Like we are essentially running parallel infrastructure with Ethereum that creates a higher level of trust for interoperability solutions or Oracle solutions, but like at the cost of latency and at the cost of like actually having to wait for the proof to be generated, right? So it's actually going to kind of merge in the middle as opposed to like, okay, we could ZK prove Ethereum, like, let's just do it, right? Like, it's not going to be a switch, it's going to be a change. And I don't think you can build a system that interacts with the rest of society without a layer of social consensus, right? You can essentially, like, if there's a bridge hack, right? And all funds within a certain address are essentially stuck, there are ways to change
There
or
are.
fix that situation, right? Um,
Well, the question is how fast do you allow things to move, right? That's
yeah,
the issue. Like, if you can instantly convert it into cash and be gone,
that's
it's
true.
it doesn't
Yeah,
matter.
that's true. Well, I mean, like, that's actually a really interesting question because you're asking the reverse of like the Ethereum roadmap.
Right.
So there's a layer two design called based rollups. Tycho is currently the leading implementation currently, and they delay finality beyond ZK finality, specifically for this reason. But the question, like the ideal for based rollups, are that you have one block to achieve ZK finality of your rollup and you can update state within a single block time. So in that state, if you compromise an L2 and withdraw all the funds, first you have to generate a valid CKP of doing that. So like you've completely owned the chain. You would be able to drain their bridge regardless. Um, but what we're essentially saying is that you can speed up the native bridge to essentially be a single block. There's benefits to this because you then get composability with other smart contracts. The risk is inherent. The risk is inherent that like you essentially can get drained. But arguably, like you can get drained in a DeFi protocol, right? Like
Sure.
you can get drained in something that is like deployed on the same chain. Um, we've always kind of dealt with it in certain ways by taking mitigating steps until we felt that it was time to actually take away the safety wheels. I feel like we're going to do the same thing with ZK. Um, and yeah, I'm actually not too concerned about like ZK out accelerating like the social consensus because we've been talking about the promise of ZK for so long. I feel like we're only just catching up to its potential because the developer velocity given ZK VMs has finally started like getting some real traction.
Yeah, no, I mean, I think it pushes the trust where you need to have it, right? It forces some bigger discussions. Like we all like to pretend Ethereum is very, very decentralized because it has a lot of people running compute.
Yeah,
And doing this, and it's like, no, like that's actually not what makes it decentralized in any way. You know what I mean? Like there are other things more that are more crucial to it, and you can have decentralized systems without paying lots of money to have people run the same programs over and over. Um,
it's true. Yeah, there's like an entire design space that's going to be opened up, and I'm not entirely sure which way it's going to go, but
well,
what I am pretty
yeah,
sure, yeah,
like on the same note, I think it's like, there was, I would say, like what characterizes DeFi and most blockchains over the last 5 years is this regulatory arbitrage, right? Like we're going to have a whole bunch of people running our compute for us, and that way we can say we're decentralized, serve the crypto market, and not comply with a lot of regulations, right? Um,
yeah.
and
I mean, that's
s-
a
it's the
way that,
cynical,
yeah,
yeah, the very cynical view of it. But like with ZK proofs, like you're like, listen, like you guys are still the only people running the proof. Like, like you don't actually need all of this stuff. So like, what's are you? It actually puts it more like, oh, you're actually not decentralized. You're just paying a bunch of professional validators to run it on several different machines. Um,
But I mean, if so are you saying that essentially by not re-executing the transaction, you have a smaller decentralization set? Because arguably, like within our marketplace, provers before they like actually auction and bid to prove, they do run the execution themselves against the inputs and verify that it is a valid state transition.
But
It's
like
just that,
it's not a
yeah,
metric. You can't. It's not a metric that you care about as a user necessarily. Like how
no,
many
it's
people are doing
not.
it. Right.
Do you care like the difference between like I know 16 validators is too little. EOS
Right.
showed us that.
Well, yeah, but that's what I mean.
Yeah.
Like, like you would have like a chain that they pop up a Cosmos chain and they say that they have 100 validators and they're decentralized, even
Mm,
if, they're like, are you decentralized there? It's like, no, not necessarily, right? Like if
mm.
there's one dev team that pushes all of the changes and everybody just accepts them automatically, and, everybody's just doing it because they're being paid to run these systems, like that's not what you care about
Yeah.
as a user necessarily,
Yeah.
for any sort of
And like
security.
along that line, you can have multiple ZK VMs. So all you care about is like the new block hash, right? For the Ethereum consensus proof. You don't actually care about what ZKVM you use, right? So this is the multi-prover argument.
Yep.
And then there's also like multiple provers being able to have anyone permissionlessly participate in proving in and of itself is another way to decentralize it. In fact, like the debate of how decentralized ZK infrastructure is has actually already matured to the point where it has its own L2 beat page, right? So it's like it's new. We're at the cutting edge, and we are the first decentralized prover marketplace for ZK compute. Um, but at the same time, like L2 Beats just spun up a page on like the decentralization properties associated with ZKL2s. So like it's going to mature, and I think a lot of these concerns will probably be shaken out by actors who overly centralized and then fell over as a result, right? Just like it's happened with DeFi, just like it's happened with bridging. Like eventually, I think the market will kind of come to a little bit of stability that weeds out like the weak decentralization by simply having it fall over in production.
Or they won't care. But either way.
Or the users won't
Or
care
the
and they
users
won't
won't care.
notice and like there's no consequences and
Exactly.
yeah, yeah. I
Google
mean,
Google runs all proofs in 5 years and call it a day. Or
it's kind of interesting because like you're saying Google runs all proofs,
or
but
or some AWS data center runs everything, right?
Google recently posted a proof of concept of on-device ID verification using zero knowledge for age verification. It was like a proof of concept to like stop the privacy nightmare that is the age verification laws that are sweeping Europe right now. Right. So they built a proof of concept where, like, using the GPU acceleration inside of the Google phones, I forgot the name of the tensor cores. They basically accelerated a ZKP over like a government issued ID that can prove someone's age with ZK on device. So, like, Google actually is directly contributing to the client side proving aspect of ZK as well. So, with more investment, more acceleration on the algorithms, I think that it's hard to argue that ZK is like a net negative. In fact, like when I got into this space, and you and I are both super early, we had this vision of like one CPU, one vote in like the early Bitcoin white paper. And Ethereum took that and they're like, all right, what if it's like one GPU, one vote? In the sense of like changing the mining algorithm in order to make it so that only consumer grade GPUs can participate. Um, I think that ZK changes the problem again, like that fundamentally, because you can create a completely different architecture for a blockchain-based system in which you question fundamental properties that you've always assumed are there. For example, like why do you pay gas on a blockchain? Like why can you not have a gasless public blockchain?
I think that's my hot take call for next cycle is there will be no gas.
There will be no
There
gas
will be
if
no
you can
gas.
compute zero knowledge proof locally or using a ZK prover network like Boundless. You
Okay.
don't need gas because you've done all the work and you don't have to store anything and it's a valid state transition. Like,
Well, I mean, there will be some storage costs and some compute costs, but they'll be so minimal that the teams will just cover them. And it'll
exactly,
be, yep.
exactly.
It'll be, you'll put in spam filters like a normal website. A normal website
Yep.
doesn't charge you for data. It's like,
Exactly.
yep.
And that's what really excites me because we do open like fundamentally different design possibilities for uh, blockchains. The part that scares me is like the level of change and upgrade a lot of these networks need to make are massive. I would argue that like the changes Ethereum is proposing to make to their protocol are bigger than the change from proof of work to proof of stake.
My problem with Ethereum is it'll just move too slow. It's going to be,
I mean, it's Ethereum. It
right.
works. It's like more valuable than Costco as of yesterday. Happy 10th year anniversary, Ethereum.
Yes.
But also, Ethereum is like no longer likely to be the first to implement all of this stuff. But they are responsible for most of the investments in ZK. And as a result, like they've kind of always had this vision and often I don't give them enough credit for the fact that it might actually work out now. But to be fair, like until I drilled into how far along RISC Zero was, I didn't think they would get there anytime soon.
But I mean, kind of back to our first point on, you know, do you think we need global consensus? Or
I
for
think
which things are we going to use it for?
so ZKVMs have this thing where you can aggregate proofs and you can keep combining them into a single hash.
This is like the Mina
Yeah,
thing. Yeah.
yeah. Um, the cool thing is that you can do this ad infinitum. So there's actually no upper limit to how much information you could compress into a single hash.
I think there is. I
It's
anyway,
time, it's
yeah,
time, energy, like resources. There are obviously like fundamental
constraints.
limits to
Yeah.
like to the system, but if you keep recursing these proofs, there is actually no bound to like you can prove Ethereum, you could prove like a base archive node, you could prove like you literally can prove anything,
Well, I think like
right?
yeah. Oh, yeah, I'll look it up later.
So
But
the consequence is like, does it make sense to actually have a consensus layer that sequences transactions in a singular like system so that it all boils down to an Ethereum block hash? Um, I mean, it's possible, but you're much more likely to have local consensus that aggregates to like a main network eventually. Um,
yep.
this is kind of already happening. And like, I don't think that ZK is going to break the sovereignty of chains. Actually, not at all. I feel like um, it actually creates a layer that is execution environment agnostic.
No, that's like I don't think it messes with like the sovereignty of chains. I just think it makes kind of like the end game is like every user is a chain in a way.
Yeah.
Like and
Yeah.
it you push it out
Uh,
even farther. Like there will be more like every app like at least every app is a chain. Uh
yeah. Yeah. I mean, you need consensus for composability, and then you would just basically cluster your application logic around that.
yep. All right. We're coming up in like an hour, or I think we may be past it. Uh so you've been around for a while. Um what's a hot take on where crypto's going?
A
What's
hot take on where
Yeah,
crypto's
but not that we already talked about. Let's maybe
going.
in DeFi or some other space that is completely unrelated.
Hmm. I mean, I view myself very much as a builder. I'm feel like I'm working on probably the most interesting and like consequential area of technology. I feel like there's certainly underhyped segments of cryptography specifically. Um, but yeah, I don't really have hot takes, honestly.
All
And
right.
if I do, I've probably already gotten them out of my system.
Well, I mean, we
Um,
we can ask, like what's the if somebody wants to build in this space now, what would you have them do? Like what idea out there do you want to s- to see built?
to manifest,
Yeah.
I personally believe that the first thing that's going to be revolutionized by ZK is bridging. And I feel like there's a
Agreed.
massive arbitrage opportunity in latency between settlement currently. And I feel like ZK explicitly with L2s, like we have this stack called Kailua, and it's able to finalize OP chains as fast as you can prove them in ZK. And I don't think that people have really kind of grasped the consequence of this because I'm looking at the architecture of like fast bridges, like intense based protocols, and I don't see them using ZK on the back end for settlement and aggregation. Like that is such a low hanging fruit and it's going to happen immediately. But the second part is once you actually start speeding up finality, on ZK enabled applications. And as soon as someone starts integrating ZK finality, like in an OP chain, let's say like you have a OP mainnet, you have a 7 day finality window for like the official bridge. With ZK, like even if we just take the fraud proof game and implement the fraud proof game we've designed called Kailua, you're down to 3 hours. So we basically just run the fraud proof game in ZK in a single round.
But I think it's the social layer thing you're missing.
There is the social layer thing, but there's also
Yeah.
still like sufficient time and there's sufficient mechanisms built into it to be able to enable that as well. Um, and then there's also the ability to upgrade to validity. And once you basically upgrade to validity, then it's no longer a fraud proof game. As soon as you prove that the transactions happened in the L2, then you can use the native bridge and withdraw. You're going to see those times just crash to the point where we were actually having discussions with OP about it being less than Ethereum's block time very soon. And then what happens then? I think that design space is really interesting because when you have financial information that travels faster and you have the ability to accelerate that information getting somewhere, right? Like you as a ZK prover, if you like have the ability to fast forward finality of a specific chain, you have this massive information asymmetry with like the root chain as well. And I think that's a really underexplored area of how that's actually going to impact certain things because we have relied quite heavily on the social layer. What happens when the withdrawal times really start like getting crunched to the point where they can be sub block finality? Um, it's a super interesting design space. I don't have a solution to it, but I do think about like the consequences of it. And like we both saw kind of what happened with MEV and the rise of like people essentially mining mempools and sniping transactions and then like reorging transactions because it's beneficial and they could sandwich certain transactions. Like I have a strong feeling that when we achieve privacy enabling ZK, MEV is going to actually disappear because there's no informational advantage to having like early insight to finality, right? But until then, you're going to have this like crunch in which the finality windows get faster and faster, not just between L1s and L2s, but between L1s that are ZK proven as well, because you have this very interesting interoperability dynamic by proving both chains. So yeah, I think there's going to be like a new version of MEV that's essentially going to take advantage of this kind of like um, speeding up of consensus through proving.
I mean, I hope. My fear is that it turns centralizing. It turns into hardware races or it turns into um, Wall Street-esque, just payment for order flow type stuff. Um, you
Yeah,
know,
that is a possible outcome, but I'm hopeful that it actually turns into client side proving. And like
yes,
rather
sir.
than Flashboys 3.0, it becomes like the actual cypherpunk shit we've been trying to build forever.
All right. Well, we shall. Where can people find out more?
You can see our network being launched on beboundless.xyz. You could reach out to me on Twitter at Societal Ruin. And yeah, thanks for listening.
All right. Thanks, everyone.